In this video, we're going to talk a little bit about what big data is. We're going to try to define the term and leave you with a good understanding of what people mean when they say it. First of all, when we talk about big data, we're typically talking about these three V's: the volume, the velocity, and the variety of the data itself. Volume obviously refers to the amount of data that we're storing, which is sometimes hundreds or thousands or millions of times what we just had a few years ago. It's not uncommon to find organizations with hundreds of terabytes or possibly even petabytes of data. Velocity refers to the amount of concurrent access to that data and the latency around getting that data out of the system. Typically, when we're talking about velocity, we're talking about a lot of folks accessing a lot of data at once, maybe hundreds or thousands or millions of people concurrently trying to pull data out of a system. Variety has to do with the different types of data. These days, we're seeing very different kinds of data than we just saw a few years back. We have one single data store, and we want to store different kinds of structured and unstructured data inside of it. Structured typically refers to data that has some specific structure about it, like a database dump or a comma-separated value or tab-separated value file. Unstructured data is typically things like dumps of chat logs or emails itself, where the text inside doesn't follow any particular structure. So what are the drivers around big data? When we talk about the drivers around big data, we're typically referring to the things driving the science, financial, ubiquitous computing, the web, the mobile, and the Internet of Things, or abbreviated IoT. Zooming in on each of these, science is probably one of the biggest drivers of big data these days. For example, we have the CERN Super Collider in Europe, which is now kicking off 40 terabytes of data per second. NCAR, the National Center for Atmospheric Research, has a Yellowstone server that stores 11 petabytes of data, unheard of just a few years ago. Financial organizations are using things like large-scale financial modeling and risk analysis to determine, for example, when a customer is almost ready to go bankrupt and potentially reach out to them and capture some of the money before they are completely out. Ubiquitous computing is something that's seeing a lot of growth these days, where we have point-of-sale systems like Target or maybe Walmart that's tracking your Super Saver card and matching up your purchases to other folks' purchases, so maybe they could send you coupons in the mail for other products you might be interested in. Auto electronics is something that's growing like crazy as well, where we now have the Tesla car that has inside of it many sensors that reach out not only to the internet, but to the car itself, and are able to tell you what's going on in the vehicle. General Electric also made the news recently with these hundreds of sensors that they put into jet engine turbines. The sensors not only look out for things like when a part is failing, or maybe when it needs to switch over to a redundant piece, but GE is also collecting all of this data from all these turbines to help them build better jet turbines going forward. Web is something that's driving the space like crazy, where we obviously have years and years, maybe decades, of web logs at an organization that we want to go back and analyze. The online retail space is driving this like crazy as well, with large retailers like Amazon doing A/B testing left and right. We also have cookie tracking, or advertisers trying to figure out what you've seen and how deep you are in a sales funnel. Analyzing the products that you've researched before and that maybe you're interested in can help advertisers put in front of you ads that you might be interested in better and click on more. We also have the whole democratization of content phenomenon, where we have not only thousands or maybe hundreds of thousands, but possibly millions of individual users contributing content to the web. Being able to crawl over that data and quickly determine which articles are relevant when users come back to search is basically how companies like Google and Yahoo drive their search engines. The mobile space is also something contributing to this as well. The planet now has 5.5 billion cell phones. 800 million of those are smartphones, which kick off extended sensory data like geolocation or compass or the tilt of the device. We have companies now building on top of that with the Internet of Things, including wearables and sensors and home automation, things like the Nest thermostat, which maybe not only collect data on your particular temperature in your house, but maybe compare that to neighbors in your area. Being able to analyze all that data can help us find out if we're maybe spending too much or if we're heating our house more than our neighbors. So basically what's driving this is really you and this amazing digital space that we live in. We're all kicking off more and more data, and that's a trend that is likely to continue. The good news is that storage is something that's really caught up to this and is really allowing us to capture a lot more data. Raw disk, or the ability to store this data, is now pretty much cheap or free, and we have organizations sitting on decades of raw data that they want to go back and analyze. Again, as we've seen in the previous slides, we have more and more devices kicking off more and more data all the time. I think it's safe to say that storage will continue to get cheaper moving forward, and that we'll all be storing a whole lot more data in 10 years. We also need the ability to process these things at scale. Storing data is fantastic, but we need the ability to go back and analyze that data. and analyzing large data sets requires something called distributed processing, where maybe we have multiple processors all going over this data at once in parallel. We also have the phenomenon of multiple analysts maybe wanting to go in and access and process data simultaneously. We don't want to queue things up and have only one analyst at a time working on data. So how big is big data going to get? The truth is, nobody really knows yet, but this is why we need our systems to be able to use something called horizontal linear scale. We'll talk about this more in upcoming slides. We also need these systems to be designed as distributed from the start. Systems designed in the last 5 or 7 years or so have distributed computing built in from the start, with NoSQL engines like Cassandra and HBase, and analysis platforms like Hadoop. These systems also need to be cost-effective. An analysis engine like Hadoop may have hundreds or thousands of nodes inside of it. The individual cost of each of those nodes needs to be as low as possible. The systems also need to be incredibly easy to use and accessible by folks who maybe don't even know what distributed computing is. If you're familiar with the cloud model, you'll see that a lot of these requirements are very similar with what we have in technologies like VMware or AWS, and we'll talk more about this in upcoming slides as well. Hopefully, we've left you with a good definition of what big data is, and you'll be able to explain it to your friends now. As with a lot of the slides that we'll see, there's also an appendix attached to this that has additional links to learn about more of each of these terms. Hope you've enjoyed this deck and are looking forward to the upcoming slides as well.